So yeah, of course. So today what I understand the goal of the session is to interact about collaborative data design, to give you to also maybe share some thoughts and sometimes opinionated thoughts. So I will try to make clear that sometimes this is just my opinion, and maybe you can disagree. You can disagree, of course, but also some practical experiences and some tips and tricks about the tools that I battle tested more or less for collaborative data design. And eventually, I think the most important is to connect. So that's why it's very important to be able to communicate in order maybe in the future to collaborate on data at some point for some good and exciting project. So first, maybe since we are not so many, I think we are less than 10 or something like that, maybe we can just enjoy a couple of minutes to get to know each other. So if you don't mind, as an icebreaker, I will start with me, which is not super humble, but and then maybe we can just have a review of who is there and what do you expect from today's presentation, and what's your current commitment with collaborative data design, for example. So about me, so I'm as I told you, I'm a PhD student working on innovation diffusion. My background is both in econ and data science, and I'm also actually from my data science background. I am an advocate of open source, and I'm also a co-contributor or maybe of two projects that maybe you have heard about. For example, during the i3, one of the past i3 session. So one is PatCit, which is an open source project to make patent citations uncool again. So actually, we are working on patent to science, but also patent to standards and so on. So this is mainly about making patent citations, both on the front page and in the text, usable for researchers in an open source way. But also, I'm also working on PatCit, which has been presented a couple of months ago at an i3 session as well. And this is a soon-to-be, this is not yet the case, a soon-to-be open source project, which goal is mainly to extract as much information as possible from old age patents, and in particular to localize patentees since the 19th century in Europe and the US. So I think that was quite a long presentation. So maybe we can start with you now. I don't know who is willing to give a bit of information about him and maybe what you expect from the session. Yes,
I'd be happy to start, Cyril.
Good. We are listening. Thanks.
Great. Hi, everybody. I'm Bhavin Sampat. I'm an economist by training. I'm on the steering committee of i3, and we're very excited about this session. So I've been using patent data for many years, and actually trying to share it for many years. And I'm here because I'm mostly a complete novice with respect to GitHub. I think I've gone as far as creating an account, but not done much more than that. So I'm really interested in learning both maybe the basics, but more than that, thinking about it in the context of sharing patent innovation data and some norms. And I'm looking forward to some of Cyril's opinions as well.
Good, excellent. Maybe Sarah, you can. No, Sarah. I know that there is someone called Sarah Schwedman, but you are on mute. Or maybe Sarah doesn't want to speak. Or maybe Carlo. Carlo, where are you there? Yeah.
Hi, can you
Yeah.
see me? Oh, great.
Yeah.
So, hi everybody. So I'm Carlo Bottai. I'm a postdoc at the Eindhoven University of Technology, and yeah, I'm working on patent data, as probably most of you. I'm trying to connect research funds for R&D to patents and then patents to products. So my current project is connected to the project by Gert Andreas and Fosse that he presented some weeks ago during the E3 meetings. And yeah, generally speaking, I mean, I'm trying to use GitHub and this type of things to try to first of all, makes my life easier. So I'm very curious about how you are using all those things to develop those projects, and then I hope I will be able very soon to release my code that I developed in the last year and on GitHub.
Yeah.
To try to create a shared project.
Okay.
Thanks.
Good. Excellent. Does someone else want to introduce himself? Maybe Benjamin?
Yeah. Then I continue. Hi, hello.
Hello.
I'm also from the, can you hear me?
Yeah.
Yeah. Hi, everyone. I'm also from the Eindhoven University of Technology, but I wasn't aware that Carlo is here. I am a PhD student. I work in the field of economics and also data science. So I am aware of GitHub. I use it, but I'm not that much into patent data yet, on GitHub at least. So I'm really curious what information is out there. I would also like to contribute in the future because I'm a big fan of this sharing and open access to this data that is so much available. And therefore, I'm looking forward to hear a little bit more about what is out there, how to collaborate, and how to use it in a good way.
Excellent. Yeah, anyone else? Or maybe we can start and maybe people can jump in the discussion. No one else?
I can go. Maybe.
Yeah, go ahead.
I put my hand up, but I don't know if it worked. Anyway, I'm Brent. I guess you can't see me, unfortunately.
No, we can't.
There we go. Yeah, okay. Yep. I'm Brent. So I was the data engineer at Creative Commons for some time, working on CC Search, which is open source search engine for openly licensed images. Now I'm at Center of Complex Interventions, working on a project called Mathazar, which is it's a tool that's supposed to help folks who are technical enough to kind of want to work with data, but not necessarily technical enough to do like database administration or data modeling. Do database administration and data modeling more easily. It's also open source. Yes, I'm generally interested in data, open source things.
Great. Thanks for that. Good. Anyone else? No? Okay, so let's go and then you jump in. Before we start, we need someone to take notes, and I think that I can do it as I'm talking. So, would one of you volunteer for that?
I can do that.
Okay, thanks a lot. Thanks. So let's go. First, I will start very shortly with a slide which answers to to the very first question we could ask, which is why collaborative data design? Why should we need it? And yeah, why should we invest time in it? So this is the most opinionated slide, and you feel free to disagree and maybe to bring some more elements to the discussion. But so my understanding is that today, if I try to represent the state of empirical research and data design on a two-dimensional plan, then I will find the two most important dimensions, according to me, are both on the x-axis, the sustainability. So for the community, the ability to update, to upgrade, and to extend on the data set. And on the y-axis, then you find the signal-to-noise ratio. So some variables are very general and won't give you a very precise signal on the concept you want to work on as a researcher. And some of the data sets are specifically designed to address the question, for example, the relation between patented innovation and scientific papers. Some data sets will be specifically targeted at that. And then the signal to noise ratio can vary over the different data sets. And my understanding today is that you've got two polar cases. On the one side, you've got institutional data sets, which are, in terms of sustainability, which are like the best we can find, because they are maintained and continuously improved by a dedicated team. And the good thing is that also the weight of it doesn't really is not supported by the research community. Most often this will be, for example, the EPO, the IMF, the World Bank who do this maintaining effort. But on the other side, most often the variables that you can find in them are very broad, and they don't always provide the best signal to noise ratio for the concepts you are working on. So typically, if you want to work on, I don't know, patent to science using PatStat, then you've got some information, you've got some data, but it's not completely parsed. It's not mapped with digital object identifiers. It's not enriched, and so on. So in the end, you've got quite a low signal to noise ratio. On the other hand, you've got question-specific data set. So very often they are designed to provide a very high signal-to-noise ratio on a precise set of concepts and questions. So typically, this would be MathMark's reliance on science data set. But what in terms of sustainability, the limitation is that they are very often created and sometimes maintained by a single research team, or maybe sometimes by a single researcher. So what happens when the funds gets expired, or what happens when the team disappears, or what happens when the researcher simply gets fed up with this data set and stops maintaining it. And so in the end, my understanding, the big question to me is that for empirical research is there a narrow corridor between institutional data sets with high sustainability but low signal to noise ratio and question-specific data set with low community sustainability and high signal to noise ratio? My understanding.
Cyril,
yeah.
Can I ask a question? By signal to noise here, do you mean essentially the quality of curation? Is that?
No, the fact that by signal to noise, I understand the fact that you have a very specific question, research question you want to address, and the data set, for example, the reliance on science data set is specifically designed to investigate this question. So if you want to, and this is the kind of thing that you won't find in the EPO PatStat dataset, for example. You won't have such details just because this is not the purpose of the EPO to make such a detailed and such a detailed data set on this specific question. But still, this is a very important question for research. And so, yeah. And so, yeah, my understanding is that this is why we might be interested in investing some time in collaborative data design. And this is what I call the empirical research, the empirical research open source moment. And my understanding is that in the long term, for the community, what the true value is not in the data, but in the data generating process. It's not the time t data snapshot which you are interested in. For example, there was a NBER patent data in 2001, which was or in the early 2000s, which was great for the community, but in the end, in 2020, the major limitation is that we are just unable to update this data set. And so this would be completely different if we had the code, the data generating process. Then we would be able to update it and then to upgrade the data set and to continuously improve on it. While today we are just like, okay, the data was a snapshot of 2001. And so, yeah, now the big question is it even possible for the community to implement such a collaborative data design? And my understanding, and what I will argue today, is that actually all we need is already there, and it's almost there for free. It has been designed by the computer science ML community for something like 20 years. And so from a technical point of view, there is absolutely no barrier in, we've got all the tools we need to develop data sets as a community and to continuously improve all together when we believe that there is a data set which should be a common good and which should be sustainable by any means. So so this was for the opinionated and the motivation part of the presentation. Now I will be much more practical, and I tried to distinguish between 3 development stages of a collaborative data design project, and in order to present the tools that are the most useful for all of these development stages. So first, there is the early development. So when you just come with a new idea and want to make sure that this will be sustainable, the project will be able to support continuous improvement by the community later on. Then there is the transition to continuous improvement, when you start communicating and trying to engage the community. And eventually there is the continuous improvement stage, where basically the project has been adopted by the community, and people are coming all around with feature extensions, with potentially some bugs and some issues that they would like to fix. And so you are able to improve the data set as a community. And so, yeah, every time I will mainly discuss some tips and tricks. So is there any question at this point? No, no one. Okay, so I continue. At the very beginning, so this will be for the early development of a collaborative data design project. So to me, at the very beginning of your journey, at the early development of the project, the goal is to make sure that the building blocks of your project will be able to support collaborative data design and continuous improvement in the future, in something like 6 months or 1 year from now. And so that's where some very standard tools come into play. First, you might want you want the future collaborators, future contributors to be able to access the code and to access the full history of the code. And so that's why Git has been designed for. So typically, I don't know if you, I think that most of you might be familiar with Git, but in the end, the idea of Git is to be able to, each time you add something to the code, to commit part of the, to commit the code and to have a snapshot of the code, and then from that you can get all the history of the code, and then when there is a bug, or when there is something going wrong, anybody is able to get back into the history of the code and then to find the right fix. So in the end, this is mainly a way to share the history of your project. And typically in a data in a collaborative data design perspective, this is key to be able to share that. Then comes the GitHub, which is just actually you might think about GitHub as a way to share and to expose your work, your coding work, to the world, but also to your team, in order to collaborate and push further your project. Eventually, what I would recommend, because very often, for example, Carlo, you told that you've got or you already have a part of a code base that you've been working on and that you would like to release later. And I've been discussing about this question with some other researchers in the past week, and they told me that the reason why they don't develop directly on GitHub, they don't expose publicly their work, is that they don't want to feel the pressure from people snooping in their code or people raising an issue. And for that, maybe something that you could have in mind is to use Gitflow. So this is very practical, but Gitflow is just a wrapper around Git, but it will help you structure your workflow, and in particular, it will help you distinguish between the master branch, which is what most people, when they arrive on a GitHub repo, look at, and then a development branch, and then feature branch, which are on the development branch. And actually, the master branch is what people see. This is something which is clean, which you pushed, for example, 1 month ago, and then you want to improve on some feature of the data or of the project. Then you can do it on the development branch with some specific features, and then people won't look at it. So they won't put pressure on you, saying, okay, this feature should go faster, or this feature should go in this direction, or something like that. And then maybe according to me, this could be if you think that the main reason for you not to push your code and to make it accessible as early as possible is that you want to avoid pressure, maybe you, for example, using Gitflow could be a good solution for you. But anyway, Gitflow is a good way to structure your approach to code versioning. This is for the code. Yeah.
May I interrupt you?
Yeah, of course.
Yeah, it's very, very interesting. What Gitflow adds compared to, I mean, you can have branches also with Git, isn't it?
Actually, Gitflow is just a wrapper around Git. It mainly simplifies the handling of a project, and especially a project with different branches. And it will also it will help you structure your workflow, And the baseline, the standard way to use Gitflow is to have this master and dev branch, and then to put feature branches on the dev. So basically, the development is never exposed to the public. It's on your GitHub, but nobody will go and snoop on the, or at least they will understand that this is still under development, and so they won't put pressure on you on this part of your work. So this is just a way to structure your workflow, but also to communicate with people visiting the GitHub and saying, okay, this part is still developing. I didn't merge it with the master branch, so just don't choose it. First, don't choose it. Second, don't put pressure on me on what I'm developing right now.
Thanks.
That's all. And so
Very interesting.
yeah.
Thanks.
I think that's one way you can use Gitflow. So of course, when it's about it's a data project, you would like to be able to version the data just the same way as you have a code versioning software. And actually, this is possible. So there are quite I would say half a dozen of data versioning software which are mature and widely used. Personally, I use data version control, which is very easy to use. And what it will do, if you are not familiar with data version control, is that it distinguishes between the data storage and the versioning of the data. So you should be aware that GitHub is not thought for large files. So typically data files shouldn't be put on the repo itself, but still you can with DVC you can store the data, for example, locally, or maybe on the cloud, for example, on Google Storage, or maybe Amazon S3, or this kind of cloud storage utilities. And still, you will commit the data as you improve it, as you do some experiments. And thanks to that, you will be able to revert to past version of the data, but also to tag some part of the data as an experiment or this kind of thing. So I'm not going to present data version DVC comprehensively today, but if you are interested in this kind of software and in this kind of workflow, you should definitely have a look at DVC, and maybe we can talk about it a bit more later. And also, so the good thing about data version control software is that most of them, they are format agnostic, so you can both version the data and the models, which is very handy because very often in modern empirical research, the data is not just about the data, but also the models that you used in order to generate the data. So the two should be versioned and stored at some point together. And also the good thing about that you might be interested in about data version control is that it also enables you to declare recipes and experiments, which will be typically a config file with both the data assets that you use, a bunch of command line functions that have generated, so for example, a data output or a model or this kind of thing. So your work will be entirely reproducible using the exact same configuration, and this configuration will be stored on the GitHub. So for the community, this is a huge step forward in terms of reproducibility, and also in terms of being able to move the frontier forward. I think. And so, yeah, you should keep in mind that this data versioning comes in the course of the development workflow, which is different from Zenodo and Dataverse, which are much more for end product. When you are happy with the V1 of your database, then you can dump it on these public repositories. While data versioning is very much a good way to track data experiments and model experiments along the way. So these are two different steps of the workflow. And eventually, if you want to make sure that that you are ready for continuous improvement later, you should make sure that your environment is stable, because you never know in 2 years what will be the software landscape, and what will be the libraries and so on. So typically with Python, so I don't know, maybe you use R, Stata, or I don't know. But typically for Python, requirements.txt, this is not enough, because it only lists the first degree of dependencies, while you actually also depend on second degree and third degree dependencies. And so for that, if you want to make sure that there is the project is sustainable, then you should use dependency package manager. For example, Poetry makes a very good work at doing that, but there are some other way to do so. So that's really for the early development. At this point, you are mainly collaborating with your team, and that's all. And yeah, you should have in mind that all the three sections that I discussed are mainly there to make sure that you will be able later to support continuous improvement and collaborative data design without such a big upgrade. Then comes the. Do you have any question at this point?
I have a question, and maybe this is a more general question. So, in terms of document, like making the code readable or explaining what it is you're doing, is kind of the best practice here. So I'm a Stata user. So I mean, it's the best practice to do that in the code itself, so sort of literate type of code, or in a separate README file, or how are people thinking about that these days?
Yeah, I will come to it just in 2 slides, or maybe in 1 or 2 slides. So the good thing today, at least if you are using Python, is that you've got this mkdoc makedoc extension or library, which will help you generate a documentation website almost for free. If your code has proper doc strings with not too many documentation, just the minimum, then you can generate a documentation website with the API documentation for free. And I will show I'm not going to show it, but I will mention and give you the resources so that you can have a look. Actually, yeah, this should be thought when you are developing, but in the end, this is just a command line. You don't have anything to do, and this is the good thing. So now, if we want to transition to continuous improvement, I would say this is something like maybe 6 months after starting the project, when you start being a bit happy with what you've done. Of course, this is not over because this won't be over at any time, but you have the feeling that maybe people could be interested in the intermediary results, and maybe they would be happy to contribute, and maybe you are also looking for some feedback and some feature requests in order to make sure that what you are doing is actually aligned with what the community is expecting. So at this point, I would say that the two main goals are to keep the maintenance cost under control, so as low as possible, and also to attract contributors. So actually, this was your question. So how to keep the maintenance cost as low as possible. First, the project documentation is key, and second, you can also make sure that the GitHub is prepared to welcome contribution and issues and feature requests for external contributors. So typically for the project documentation, I would say, yeah, definitely the first thing that you have to do, because this is what the customer is facing, if I can say, is the README. Very often when you look at the GitHub repository from researchers, the first thing that you see is just nothing. There is no README, so no one is explaining you what the repo is expected to do, what the project is, where the project is heading, all these kind of things. So if you want to be able to engage the community, but also just to avoid any mail asking you what is this project about, then a good README can definitely help. And I think that so you theoretically you have access to the Google Slides, and I linked to an external resource which explains some good practices about how to build a README. And actually, this is so the website is calmcode.io. This is made by an excellent data scientist, according to me. And so if you are interested in modern data science or data-related practical tools, this website, calmcode.io, is it's a very good place to hang around when you've got 5 minutes. So going back to the presentation, so this will explain you how to build a good README, and then comes the project documentation in a larger picture, and then you can use the mkdoc library, which will definitely help you build. Actually, this will give you a documentation website for free. This will go and inspect the code and get the doc strings and build an API doc for free. So with just a command line and a library, you can generate a fully documented website, and this will, yeah, this will make your project much easier to handle for the community, and then you can deploy it on GitHub for free as well in just 1 or 2 clicks. So yeah, so if you are interested in getting people involved and understanding what you are doing, make sure that you are writing good doc strings as you are developing, and then this is just a matter of 1 command line and 2 clicks. And also for the documentation, I know that this is not standard, but my understanding of GitHub issues, even when there is still no external contributor, you can use GitHub issues as a way to track the way you solved, at least temporary, some questions about how to tackle some part of the data or how to fix this issue with the data set. So this will typically, this can evolve from a version of the data to another. And for this kind of issues or questions that could be frequent for external contributors, or maybe people that want to use your project, you can, at least I did it, you can use GitHub issues in order to track the development of the project around these specific questions. So typically in our case, this would be the for example, when we've been working on patent to science, this would be the use of PubMed or the use of Crossref as a consolidation data set, for example. Or this, yeah, and then the rest of the community can join and discuss it in the issues as well. And also, so something that you want to do in order to make sure that you don't lose too much time with people coming and raising issues, something a bit like widely. Then you can use templates in order to make sure that when people start to write an issue or feature request, this feature request or issue fits a template. So you will impose the template to the user. And then you are sure that you have all the information that you need in order to start working as fast as possible. So these are some tiny investment at the beginning, but in the end, this might save you a lot of time. And so, of course, what you want to do next is to attract contributors. And so for that, there are I would say two main directions. So first, you want to dump the data on a public repository. And second, you want to give people some intuition of what they can do with the data set, why it's interesting. And so you might want to demo the project. So dumping the data on a public repository can be done, of course, on Dataverse or Zenodo or other public repositories, which offer some kind of versioning. So at least this will make you able to say, okay, this was version 1 of the data, version 2 of the data. And there is also BigQuery. So you might be familiar with Google Cloud BigQuery, which is a way to query live data sets which are hosted on Google Cloud on the Google Cloud platform. But you can also host your own data set on Google Cloud and make it publicly available. That's what we have made with PatCit, and what we will certainly do with PatCit soon. And so this means that anyone is able to investigate the data set in with just a single query and a GCP account. So this might be a good way also to share your data set and to make sure that downloading the data and then setting up the data on their computer is not a barrier to your project adoption. Actually, I really like BigQuery and the way it can articulate with Colab. So I don't know if you are aware about Colab, but this is mainly a notebook which is hosted which is hosted by Google. And which runs Python, and then you can share this Colab, for example, on GitHub, and then it will be versioned as well, like the rest of the code. And you can demo, you can do request and demo demo your project and what can be found in the data. So, for example, you will be able to share a notebook of descriptive statistics, which will definitely quick start anyone trying to investigate the project. So BigQuery in a collaboration with Colab will be a great work at demonstrating your and also moving down the barriers to entry to your project. So if you want to, I think this might be really helpful. So typically, this is the PatCit project, which I briefly discussed a bit earlier. And also so we've been looking at patent citations. So patent citations can go to many different kind of objects, and but also among these objects there are norms and standards, and we passed these citations, and we built a dedicated table. But what is interesting in our case is that we have hosted the table on BigQuery. We have designed a collab which is very sparse and uses calls the data set which is publicly available on BigQuery, just like you can do. And then we run some very preliminary analysis just to give people an intuition of what they can find in the data set. So typically here, this will be just the number of citations that we extracted by year of publication of the patents, but also the standard body by publication year, the number of citations, or the companies. No, this is not the companies, but here you've got the companies, the citations by companies who produced the standards and so on. So this is and actually this kind of collab, you can run it on your own. So you can access it from the GitHub, and then you can run it on your own. You don't need anything else. So I think this is a good way to, this can be an interesting way, at least for you, to share your work. And then, yeah, and eventually comes I would say, maybe we can stop there and see if you have any question. Do you have, maybe, do you have any? Yeah.
I have a couple of comments or extensions on the GitHub flow.
Yeah.
Not Git flow, sorry, but so you mentioned issues as project history, which I think is good.
Yeah.
I would also add that I have found pull requests to be fantastic. So issues track like what you were trying to do. Pull requests track the actual what you did and kind of the solutions to what you were trying to do.
Mm-hmm.
And then also I find it can be very helpful if you develop a culture on the project of really good commit messages for your Git commits, because those are really helpful for someone from the future who needs to understand the logic of why this function is the way it is, or why this line of code is confusing or something like this. Like those can really be useful.
Yeah, you're right. Yeah, and typically the documentation website might have a contribute section, for example, where these kind of things are discussed. How to write a pull request, how to write an issue, how to write a commit message, what are the specific conventions. Yeah, I definitely agree with you. And I would say that the documentation website that you produce with MakeDoc, for example, can be a good place to discuss these things and to give potential contributors the keys to contribute efficiently. Yeah, thanks a lot. And another way to demo your project, for example, if you've got some geographic data. So this is the case of Patent City, where we localize early age patentees. Then you've got Kepler, which is a very, very easy way to share localized data. And so this is what we've done here. And the good thing is that you can generate a URL from your own computer once you've got uploaded your data, and this URL will will enable anyone to access the same map and to investigate it, and also maybe to work with some parameters like the time or this kind of things here. So yeah, definitely finding a good way to demo in just one picture your project might be a good way to find future contributors. And eventually, so if you made your way up to this point, comes the real continuous improvement section. So the project is more or less the main aspects of the data sets are now done. You've got the V1, and what you want is to be able to update it, but also to upgrade it based on the community feedback, and maybe also add some major improvements. And so I will discuss two main points. First, how to integrate continuous improvement in your workflow. And second, how to make sure that the community keeps engaged or is engaged at some point. So the 101 of continuous improvement, some of you might be very familiar with GitHub and will find it very basic. Some of you might not. So I will say it anyway. So typically, so you have your code on GitHub, which generates the data, and if everything is good and that you've got you have used the data version control and the recipes and experiments are clearly logged on the GitHub, then anyone should be able to run it again and to reproduce the very same thing and then to extend on it. So if they want to experiment, then other GitHub users can fork on your repo, and so this will be just a copy of your code with the full history as well, and then they will be able to build on the shoulders of giants. But then what we want is not just reproducibility and giving the other people the ability to build on your work is great, but even better would be the fact that they help improve your project, and so this is where the pull requests come into the game. So what happens is that, okay, for example, Baiven has developed a great project, but I have the feeling that and there are some assignees in the data set which has been which have been extracted from, I don't know, any from a text data. And I would like to be able to distinguish between assignees who are a person and assignees who are a company, or maybe assignees which are a research institution and assignees which are not. And I would like to maybe to develop a classifier to do that, and then to run it and to add a field to the data set. This is something that that is not necessarily on the top of the agenda of the core contributors, but I would like to add it. So what I will do is that I will fork, I will develop my extension, and then I will do a pull request saying, oh, okay, I've developed that. I have this is how I made it. These are my performances. Would you like to integrate the code and the results into the main repository? And maybe we will discuss. Maybe you will tell me, okay, this part is okay. This part doesn't respect the convention that we have implemented since the beginning of the project. Please iterate on it, and hopefully at the end you will accept the pull request. and this will become part of the main project. And this is how we can grow the giant and continuously improve on a workhorse data set. And for the community, in the end, this is very close to what people have been doing in the theoretical world. So, for example, with DSGEs, when someone adds an extension on the workhorse on the standard DSGE, and maybe some extension will be kept by the following literature. Maybe sometimes it won't be the case, but this will be an interesting extension that people have in mind, and maybe they can go to the repo or this kind of thing. And then, so this was for the 101 of continuous improvement. And then eventually, what you want is to engage with the community. So for that, I found the new GitHub discussions very useful. So these are open-ended questions or announcements that you can do on a specific section of the GitHub. So, for example, I will say, okay, we have started to investigate patent citations NPL patent citations, which are actually patents and which are Japanese patent abstracts. So you might know. So this is a bit technical, and maybe this wasn't a good example. But if you are interested in patent citations, you might know that if a patent is cited as a translation or an abstract, then it's not a patent citation; it's an NPL citation, and so non-patent literature citation. And so if you look at the NPL patent citations, you will find what we would like to call patent citations, which would be, for example, patent abstracts of Japanese PAG. It's PAJ. It's a patent abstract of Japan. Yes, and you would like to discuss with the community what should be done with this kind of citations. And typically, GitHub discussions are there for this kind of discussion. So yeah, that's typically that's something that's a discussion that we started on the PatCit GitHub, and which has been, for example, discussed with Gaëtan de Rassenfoss, but also Kyle Hyam. And we are expecting other people from the community to join us and discuss other important discussions on how to make the most of patent citations, which have not been used so far. Also, you might want to label some issues which you might not want to address on your own, but which are a good way for new contributors to get into the project. And so you might want to help them find these issues by just tagging them as help wanted. This is very basic, but in the end, if I'm a new contributor looking for how to help you, this will guide me without me needing to send you a mail and you replying to my mail and so on. And in the end, this takes a lot of time. So we can collaborate in a much more direct way for this kind of indices that you leave on the GitHub. And also for contributors who are not always working on the project, for example, newsletters can help a lot. There are many services of which can help you having newsletters for free. So there will be MailChimp, but also TinyLetter. And in the end, this is what this is, I think, it seems to me that this is crucial to make sure that the community and people who have been interested in your project at some point will have an eye on it and maybe contribute to it in something like 6 months or maybe 1 month or maybe 2 years. And eventually, this is I would like to discuss the reward contribution. So to me, this is very important to make sure that contributors, even those who have just contributed to part of the documentation or maybe asked a question, because contributing is not just adding some code. It can be raising an issue. It can be asking a question. It can be anything that helps the project moving forward. And for this kind of contribution and being able to track all them and to reward people and make sure that they feel some reward for their contribution, there is the credit framework, which is a good way to make sure that everyone is cited, but also people who have people are assigned with a specific set of contributions. So people who have contributed on the code are not cited in the same category as people who have contributed to the models or people who have contributed to labeling the data or to the documentation and so on. So once again, this is very practical, but in the end, this is about having a healthy community. And
Cyril,
also, yeah.
Can I ask a question before because I know we're going to get kicked out of the room here soon.
Oh, sorry.
The question is, this is fascinating. As you think about what I3 is doing, I mean, is there an argument for organizing everything, like all the activities around a process that you've just discussed, as opposed to the process that we have in place right now?
That's an excellent question. I'm not sure that I'm the good person to answer. I think that if the community matures the same way as the computer science or ML community has matured for in the course of the last 20 years, no. The answer is no. We won't need the I3 anymore. But I think that the I3 is a great place to create the community and maybe make sure that in the future we can have this kind of continuous improvement and collaborative data design.
But we don't explicitly use GitHub right now, right?
No.
As a way to do things. But it sounds to like a lot of the functionality that we're trying to provide.
Yeah. Exactly.
It seems to be possible there, and it's just really barriers to entry right now and lack of familiarity that might be part of the issue.
Yeah, I fully agree with you.
Okay.
Yeah, you are right. And maybe to conclude, I think it's in terms of reward and making the community as friendly as possible. This is super important to be very generous. So, for example, Hugging Face has been an open source project developed for something like 2 years and has changed the NLP landscape in 2 or 3 years. And one thing that they do is that when you arrive on the GitHub, the first thing that you see is the contributor. It's not the company, it's not anything else, it's the contributor. And definitely this changes the people's mind about contributing and giving people the right incentives to contribute. And also make sure that the licenses and the citation are on the GitHub in order to make sure that, well, at least people who don't cite you know that they should. Because this can happen, and to put an end to conclude, even I think that we don't have time anymore. But the main questions, the main question to me was, since the technical tools are there, what can we improve to support collaborative data design? Is it culture? Is it incentives, technical skills, collective agenda? and more in some way this equals to Bayesian question. And so big question, why? What can we do, and why doesn't it exist yet? And I think that's is what I can't see the chat, Samuel, but is it the end? Yes.
Yes, we're reconvening soon.
Okay. So
Please, when you reach a satisfying pausing point.
Yeah. So I'm done, but maybe someone wants to discuss the question of how we can improve support for collaborative data design, or maybe why we don't have such initiatives so far. But yeah, I'm done at least. Anyone?
It strikes me just as that the infrastructure you laid out, and again, I'm speaking as someone who's probably a little bit behind this particular frontier, that it's barriers to entry. It's not, and right, there's the science advances one funeral at a time kind of thing. A lot of us have been doing things a specific way for, maybe many years now. And I think that might be a constraint. What I wonder if there is a way so Sam, I just asked the question, based on the presentation here, I was kind of convinced that I3 should be doing everything like the way that Cyril has kind of laid things out here. But I'm not sure that's going to be feasible for, the 40 and aboves among us. And the question is whether it can be a dual path. So whether we can essentially mirror a lot of what we're doing in the kind of infrastructure that Cyril has laid out. And then at some point down the road, the things converge. So I think that's interesting. But I came away convinced that this is the future.
Actually, if you are convinced, just give us a star on PatCit GitHub repo.
Okay. I have to figure out. I have to remember my password first. But yeah, I will. Yes, this will be a good motivation. Yeah, I mean, it sounds like that list is something I'd want to be following, but I actually didn't know about. So yeah, definitely. This is great.
This will give us a bit of credibility. Thanks. Anyone else? So good. Thanks a lot. And feel free to get in touch with me.